Our first question, we've got question 5 that is from a 2019 November exam paper. So question 5 states, simplify the following expression into one trigonometric term. So we have to simplify this such that it becomes one term. Now, if we look at this, we can see that we have sine over cos. That's the first thing that should stand out to you. That's sine over cos. What does sine over cos usually mean? We know that is an identity. Now, hopefully at this point, you should have your identities memorized. The important identities that you should know are your sine over cos equals tan, your cos squared plus sine squared equals 1, and your compound angle formulas as well as your double angle formulas. Hopefully at this point you should have them memorized. I don't think you get them on the formula sheet, so it is important to know them. I think you only get your compound and your double angle on the formula sheet. So now, our first question, we need to simplify sine over cos. So we can see that sine over cos is one of our identities. So that is automatically going to become tan x. From there, you can see that we have another tan x at the bottom. So we've simplified sine over cos times tan into tan over tan. Now, the next part we have plus sine of 180 plus x. So when we are reducing 180 plus x, we need to ask ourselves what quadrant is 180 plus x. So we know that quadrant 1 is x, quadrant 2 is 180 minus x, and quadrant 3 is 180 plus x. So because that is in quadrant 3, we then ask ourselves, is sine positive or negative within quadrant 3? And we know that sine is negative within quadrant 3. The only identity that is positive within quadrant 3 is tan. So this is then going to become minus sine x times. Now, next we have cos of 90 minus x. So what will 90 minus x become? Something important to take note of is that whenever you are dealing with a 90, you always need to remember co-ratios, or if you want to call it co-functions, whichever, it doesn't matter. You always need to remember that cos of 90 minus x is equal to sine x. Cos of 90 plus x is equal to negative sine x, and sine of 90 minus x and sine of 90 plus x becomes cos x. Now I see that there are two, okay, now there's two hands that are up. T, you still have your hand up as well as surprise. Do you guys have any questions or something that you need to mention? Okay, T, everything is fine. Okay, then the next person, surprise. You've got your hand up, buddy. What's going on? If you are struggling to unmute yourself and speak up, there's a chat option that you can use to send a message within the chat box, okay? Now, I'm going to continue. So from here, we need to identify what does cos of 90 minus x become. So we know that because that is a co-function or co-ratio, the cos is going to become a sine, and a sine would become cos. So automatically you can just put in your sine. Then you ask yourself, okay, we need to identify if this is going to be positive or negative sine. So we ask ourselves, what quadrant is 90 minus x? So we know that 90 minus x is quadrant 1 and 90 plus x is quadrant 2. So because 90 minus x is in quadrant 1 and cos is positive in quadrant 1, it then means that our sine x will remain positive sine x. So we've now simplified this expression in our first step. Next, what we can do is take it a step further by dividing tan x divided by tan x and multiplying negative sign times positive sign. So let us continue. From here, tan x will cancel out tan x, leaving us with positive 1. Next, we have negative sine x times positive sine x. Now that is going to give us negative sine squared x. Now, 1 minus sine squared x should look familiar to you. That is an identity that you should have memorized. So cos squared x plus sine squared x equals 1. If we were to now move sine squared x to the other side, we would end up with cos squared x equals 1 minus sine squared x. And that is exactly what we have over here. So from this, we can see that 1 minus sine squared x is equal to cos squared x. So that is our single trigonometric term. And that is where we will end with question 5.1. Now, our goal for question 5.1 was to only simplify our expression into a single trigonometric term. And we've done that. So we are done. There's nothing further that we need to do. Now, if we look at question 5.2, it states calculate without a calculator, determine the value of sine squared 35 minus cos squared 35 all over 4 sine 10 cos 10. So from looking at that, you can see that we have a lot of double angles within that question. So let's write it out. Sine squared 35 minus cos squared 35 all over 4 sine 10 times cos 10. Now, let's look at the numerator. Our numerator looks familiar, but it's not exact. So if you go back to the last page in your formula sheet, you will come across your compound angle formulas and your double angle formulas. Now, sine squared of x minus cos squared of x looks similar to one of our double angle formulas for cos. Now, if we were to change it such that it looks the same as what we have in our formula sheet, because keep in mind, on our formula sheet, we have cos of 2x is equal to cos squared x minus sine squared x. But we have it swapped around. We have cos as negative and sine as positive. So how do we get sine to become negative and cos to become positive? The easiest way is to just factor out a negative sign. So if we factor out a negative sign, cos will then become positive and sine will then become negative. Now that looks similar to what we have in our formula sheet. So we can now then go and substitute cos squared, or rather cos 2 of 35, not squared. So in place of cos squared 35 minus sine squared 35, we can now substitute cos of 2 times 35. So that is only the top part. Let us now go and have a look at the bottom, our denominator section. So that also looks quite familiar. If you go to your formula sheet and you look at the double angle formula of sine, the double angle formula of sine looks like this. But we have 4 instead of 2. So how do we turn a 4 into a 2? we just break it up. So from here, we can take out 2 as a common factor, and we'll be left with 2 sine 10 cos 10. Now that looks identical to the double angle formula of sine that we have within our formula sheet. So let's move on with our question. We've previously mentioned that within the bracket of our numerator, we are going to substitute cos 2 of our angle, which is 35. And in place of our denominator's bracket, we are going to substitute sine 2 of our angle, which is 10. Now, from there, we need to ask ourselves, how do we simplify this? We've got 2 times 35 and 2 times 10. Can we not multiply them? So that is then going to become negative cos of 70 over 2 sine of 20. Now, there's something important that you need to be able to identify once you get to this point. That is co-ratios. Always remember that anything that adds up to 90 or when subtracted gives you 90, or when there's an actual 90 within the expression, always think of co-ratios. So you need to train your brain such that you are able to identify co-ratios immediately, because that is very important. As soon as you see anything that adds up to 90, anything that when subtracted gives you 90, or anything where there is an actual 90 within the question, automatically you need to think of co-ratios. It is very important. So if you look here, we've got 70 plus 20. 70 plus 20 should automatically click and say, okay, that's 90. So because it's a co-ratio, it then cancels one another out. So cos of 70 cancels sine of 20, because when divided, they give you 1. The reason behind that is because we can change one of them to become the other. So if we were to change sine of 20, sine of 20 can be rewritten as sine of 90 minus, sine of 90, yeah. If we write sine of 90 minus 20, right? That's going to end up giving us cos of 70. So as you can see, if we were to replace the sine of 20 with cos of 70, we'd have the same thing on the top and at the bottom. All we are now doing is skipping the step whereby we change it and introduce the 90. We automatically just know if it adds up to 90, and if it's two different identities, then we can cancel them out. But if you had cos of 70 over cos of 20, those are not co-ratios, because you can't convert one of them to the other, because it's already the other thing. For example, if you had cos on top, cos at the bottom, if you were to convert one of them, you'd end up converting it to sine. So it can't cancel out. Sine and cos can't cancel out, because we can't convert it to the same thing if it's already the same thing. Now, if you look at this, we've got cos, we've got sine. You can convert one of them. You can convert the bottom one, sine 20, you can convert that to cos 70. You can convert the top cos 70 into sine 20. They can be converted into the other thing in order to cancel out. So to avoid all of that whole long introducing all of the 90s and the whole steps, all you need to do is remember, if it's different, meaning that if one is sine and the other is cos, and when you add up the angles, it gives you 90, automatically just cancel them out. If you want proof of that, you can put it into your calculator. So if you want to be sure, you want to be 100% sure that you're not making a mistake, you want to double check your working out. Even though the question said without using a calculator, no one's going to know if you use the calculator, because you have your calculator on your table. No one's coming through your desk or coming past you checking each question if you use the calculator or not. And the fact that they allow you to bring the calculator into the venue means that the rule is not that strict. So if I were you, I would just put it into my calculator, cos 70 over sine 20, and you'd see you'd get 1. That's proof that they cancel out. So always keep that in mind. It is very important to remember, if anything adds up to 90, if anything once subtracted gives you 90, or if you see a 90 within the question, automatically think of co-ratios, okay? Yes. Now, let us proceed with this question. This cancels this, and we are then left with -1 over 2. Now, that is our answer.
Good afternoon, sir.
Hi, Ntombi. Kaise?
Yes, sir. I just wanted to check where you got the -2, the negative cos 2 in brackets 35, but now I saw how you got it.
Okay, perfect. So anyone else that has the same question, how I obtained the how I obtained negative cos 2 of 35. Keep in mind that if you factor out the negative, that negative is going to move one side. You keep it on the side. You don't touch it for now. Just leave it there. In brackets, you've got cos squared 35 minus sine squared of 35. That's what you are left with once you factor out the negative. Now, from that point, you can put that, or not put that, but rather go to the back of your question paper and look at your formula sheet. You'll see that cos 2 of theta, or cos 2 of x, whatever you want to deal with, or whatever you want to assign as your angle, cos 2 of that angle is equal to 3 things. One of those items are cos squared of theta minus sine squared of theta. So that is how I was able to take cos squared of 35 minus sine squared of 35 and make it cos 2 35. It is because that is a double angle formula. Hopefully at this point, June exams are quite close. You should already be able to do that without looking at your formula sheet, right? So let us continue. Now for question 5.3, it states, given cos 26 equals m. So keep in mind, this is the rule that we were given, or the little piece of important information. We need to keep in mind that whatever we do, we need to remember that cos of 26 is represented by the variable m. So our next part says, without using a calculator, determine 2 sine, or rather 2 sine squared of 77 in terms of m. So because they've stated that cos of 26 is equal to m, and now we need to get 2 sine squared of 77 in terms of m, it means that somehow with simplifying 2 sine squared of 77, we need to somehow get cos of 26 within that, or we need to turn 2 sine squared 77 into something that has cos 26 in it, right? So let's see, how can we change that? So we've got 2 sine squared of 77. Now, if you notice, the general pattern of this question has been to deal with co-ratios. We've been dealing with that quite frequently. We've attempted, this is our 3rd question so far, so we've almost attempted 3 complete questions. In question 1, we dealt with co-ratios. In question 2, we dealt with co-ratios. So it's now become a common trend within this question. So that should be a clue for you to say, okay, I did it in question 1, I did it in question 2, most likely I'm going to do it in question 3 as well. So if you look at 77, what can you convert 77 into? Because keep in mind, we need to get cos, but we have sine. So how do we turn cos, or rather, how do we turn sine into cos? We use co-ratios, because remember I previously mentioned that sine can turn into cos and cos can turn into sine using co-ratios. So you can see it's now become a trend that we're going to make use of. So from here, what I'm now going to do is I'm going to separate the squared. I'm going to try and put it on the outside so that I can deal with the inside. I don't want the square to confuse me, and I don't want the square to get in the way of my calculation. So I'm going to put it on the outside. So this is going to be 2 into sine of 77 squared. That's still the same thing. I've not changed anything. I've just moved it to the outside. It still technically means sine squared of 77. Okay. Now, just an important side note. If you see the squared outside, please don't square 77 and go put a huge number in there. That's not what it means. The squared is for sine, not for 77. Okay. Now, let us proceed. How do we change this sine into cos? We're going to introduce to make it a co-ratio. So what number am I going to put after the minus sign? I need to put a number such that when I subtract something from 90, it needs to give me 77. So if I subtract 13 from 90, is that not equal to 77? So technically, I've still not changed anything as yet, because if I were to simplify 90 minus 13, I would end up with 77, which will take me back to the previous step. So everything is exactly the same. I've not changed a single thing. I've just represented it in a different way. Okay, so let's proceed. Now, I previously mentioned that whenever you see a 90, your brain needs to light up. You need to think, okay, co-ratios, I see a 90. So we see a 90 over there. So what does that mean? We now need to change this. From sine, it's now going to change to cos. So we bring down our 2. Can put in my squared brackets and my squared. Let's simplify the middle. What is inside my squared bracket? So because I have that 90, I've already stated that it now becomes a co-function or co-ratio, whereby I can convert that to cos. So step number 1, we ask ourselves 90 minus 13, what quadrant is that in? It is in quadrant 1. And sine is positive within quadrant 1. Therefore, I'm not going to put a minus sign. It's going to remain positive. Then we ask ourselves, okay, because I have sine, what is the sine turning into? It's going to turn into cos. So sine will turn into cos and cos will turn into sine. Always keep that in mind. So this is now going to become cos of 13. From here, we can continue. Do you see how cos of 13 is quite close to cos of 26? So we're moving in the right direction. So let's continue. So from here, we have 2 cos squared 13. Now, please keep in mind, you cannot multiply this 2 with the 13 and say cos squared of 26. It does not work like that. If the 2 was within cos, meaning if it was cos squared of 2 times 13, then we could have done that. But because cos is, or rather because the 2 is on the outside, we cannot multiply it with the angle on the inside. That is very important. Please keep that in mind. So how do we now turn this into something that is cos 26? Because we're close. We can see that 13 is almost there by 26. We're very close. What do we do? So go back to your formula sheet. We've been dealing with double angles for cos as well, right? So what are the few double angles for cos 2x? Let's see. If you go to your formula sheet, you've got the first one being cos squared of x minus sine squared of x. The second one is 1 minus 2 sine squared of x. And the third one is 2 cos squared of x minus 1. So if you look at it, the only one we can use is the third one. All the others have sign in it. So before we do this, a question could come up. Why did I decide to use my double angles for costs? What led me to go from, okay, I have 2 cos squared of 13. Why should I now introduce double angles? What train of thought led me to that process? Now, if you look at it, you've got 13. Is 13 not half of 26? So if you were to double 13, you would get 26. Because from this point we're stuck. There's nothing much that we can do besides put this into our calculator and get a decimal. But we don't want a decimal. We want something in terms of m. And no matter what we put into our calculator is not going to produce a value that has m in it, right? It just doesn't work like that. So we need to now come up with a solution of how can we turn 13 into 26. The only way that we are taught in grade 12 to turn the value of theta into 2 theta or to double an angle is to use double angle formula. So that is why I've now decided to introduce my double angles. So let's use that. If you look at what I have, which is 2 cos squared of 13, and what the formula is, which is 2 cos squared of x, what's missing? That minus 1. Now, how do I get my expression to have minus 1 in it? Because I can't just go and add my own numbers in there and do whatever I want. It doesn't make sense. Math doesn't work like that. You have to abide by the rules, right? So what I am going to do is I'm going to add 0. If I add 0, I've not changed anything. Technically, I'm adding nothing, which means I'm changing nothing. So I'm going to add 0. So minus 1 plus 1. That is technically 0 because negative 1 plus 1 is nothing. So I've done nothing to change it, because if I were to simplify that, I would get back to my original. The whole purpose of adding that nothing, of adding that 0, was so that I could have this minus 1, because I know that that minus 1 completes my double angle formula. So technically, you've done nothing wrong. You've not changed anything. You've just added 0. It's the same as multiplying, or rather, it's the same as rationalizing a denominator or rationalizing a numerator. For those of you that are familiar with the process of rationalizing a numerator and denominator, all you do is multiply by 1, right? Even though you've got your numerator that looks fancy, your denominator that looks fancy, technically all you're doing is multiplying by 1. If you multiply by 1, you change nothing. Okay, so keep that in mind. Now here I've added nothing. Negative 1 plus 1, that's a nothing. So it's still the same thing. Now from here, this is now going to become my double angle formula, which is cos 2 of 13 plus 1. From there, 2 times 13 gives me cos of 26 plus 1. And we know that 26, or more specifically, cos of 26 is equal to m. So all I'm now going to do is substitute m in place of cos of 26 and add my plus 1. So that is it. I did not change anything by adding negative 1 plus 1. It still stayed exactly the same. All I did was I used the rules of algebra that I am familiar with to manipulate the question so that I can get what I want. Okay, so I'll take a break there to see if anyone has any questions. I think that's the third question we've completed thus far. So okay, I do see there are a few hands. Just give me a second, please. While I'm attending to the hands, those of you that have a question and are feeling shy to speak up, you're welcome to type it out in the chat box. Before I attend to the hands, let me zoom out. That way you can have a look at all 3 questions that were completed so far, in case you have a question regarding one of them. Okay, hopefully you should be able to see all three. If you are using a cell phone and you cannot clearly see, just zoom in the same way you would zoom into a picture. It works the same way on Teams. And if I'm not loud enough, the option in the middle, it looks like an audio icon. Just click on that, click on speaker. So you should have a tick next to speaker. It will magnify my voice if you do not have access to to headsets. Okay, so Rato, you have your hand up, and Mufunwa, you have your hand up. Please unmute yourself so you can ask your questions or mention what you need to.
Hi.
Hi. Hi.
Explain how we got rid of the brackets in the fourth step.
How I got rid of the brackets. 1, 2, 3, 4. Are you talking about those white brackets that I've introduced over there?
Yes, sir.
Technically, those are not brackets from the question. I just introduced that for you to see that part is the double angle formula. It's not actually, you don't even need to put that in your question. It's just so I wanted to highlight that is the double angle formula part. That part in brackets, in the white brackets, is turns into cos 2 of 13. Does it make sense?
Yes, sir, it does. Thank you.
Perfect. Then Mufunwa, you've got your hand up, buddy. What's your question?
Good evening, sir.
Hi, Mufunwa.
So I wanted to ask more about rationalizing the -1 + 1 part in step 4. I don't quite understand it. Could you please explain it again for me?
Okay, so technically that's not rationalizing. I was referring to the rationalizing part for you to use a reference for those that are familiar with the concept of rationalizing. But what I've done in there to add -1 + 1, keep in mind my formula was kind of short. I only had 2 cos squared of 13. That's not enough, or that's not the complete double angle formula, right? So because that's not enough, I needed to then introduce that -1. But I can't just randomly go and put a -1. It doesn't work like that. So I had to introduce something that does not change the actual value of this. Think of it like if your friend gives you 100 Rand tomorrow and then after 2 hours takes it away. So technically your friend didn't give you anything. You still ended up with 0 at the end. So that's all I did. All I did was I introduced -1 and +1 such that it is introducing 0. I've not changed anything. An alternative approach to that specific line would be this. So if you know that, just give me a second to zoom in. So if you know that cos 2x is equal to 2 cos squared x minus 1, right? But we only had cos squared of 2x, sorry, cos squared x, 2 cos squared x. That's all we had. This is the only part that we had, 2 cos squared x. Think of it like what we did with the previous identity. Cos squared x plus sine squared x equals 1. Now we previously had 1 minus sine squared x equals to cos squared x, right? Now we did this, or we got this by moving it around. So you can do the exact same thing with your double angle formula. Why not move it around? So if I move this -1 to the other side, it now becomes cos 2x plus 1 equals 2 cos squared x. Now, if you notice, that's exactly what I have. So cos 2x plus 1, do I not have cos 2x plus 1? I just did it in a different way. I just introduced 0. That's one method. It's not the only method. Another method would be to write out your double angle formula equation and solve for 2 cos squared x and substitute the remainder of it, or what 2 cos squared x is equal to. Does it make sense, Mufunwa?
Yes, it does. Thank you.
Okay, perfect. Okay, then I see there is a question in the chat. Just give me a second. I didn't understand how we got 1 when you added 0. Okay, so I added 0 because -1 plus 1 equals 0. If you have -1 and you have +1, in the end it's 0, it's nothing. You can do the same thing with x. I could have introduced -x plus x and that would have given me 0. I'm introducing 0. Now let's have a look at 5.4. So before we get to 5.4, let's read. Consider f of x is equal to sine of x plus 25 cos 15 minus cos of x plus 25 sine of 15. So just by reading that statement, there's something that's important. There's something there that should pop out to you. That is the repetition of 15 and x plus 25. So if you notice this x plus 25, it repeats itself. And then the 15 also repeats itself. Why is that? Then we have sine, cos, cos, sine. Does that not remind you of your compound angle formula? You've got two angles repeating themselves and you've got sine, cos, cos, sine. That looks like our negative sine compound angle formula. Okay, so just keep that in mind. Next, we have question 5.4.1. Determine the general solution of f of x equals tan of 165. Now, we previously did general solution, I believe maybe 2 months back. So I'll go through all the steps. Hopefully, if you do remember what we did previously, it'll make it easier. And hopefully you should know since exams are around the corner. But there were 3 items of importance that we needed to know when discussing general solution. The first being, what quadrants are those items positive in? What was our reduction formula? And we needed to know how to obtain a reference angle. So those were the 3 important pieces of information that we needed. So let us now try to solve 5.4. Okay, so it's going to be f of x equals 165. So this is question 5.4.1. We have f of x is equal to tan of 165. Now, f of x was equal to, let's have a look, 25 and 15. Okay. So that is going to be sine of x plus 25 cos of 15 minus cos of x plus 25 sine of 15. That is our compound angle formula. Now, that is our compound angle formula, more specifically our negative sine compound angle formula. Because as you can see, I'll write down the formula now to make it easier for you. That is A. That is going to be cos of B minus cos of A sine of B. So you can see the repetition of that angle of 15 and x plus 25. You can then see the repetition of sine and cos. So this is equal to sine of A minus B. So in place of my left-hand side, I'm going to put sine of A minus B. A is going to be x plus 25 and B is going to be 15. Now someone could ask, why don't we say 15 minus x plus 25? Why is it x plus 25 minus 15? Now the reason for that is because A represents the first angle used and B represents the second angle used. So we have to subtract the first angle minus the second angle. always. Don't just subtract any angle you feel like subtracting. So that is then going to be sine of x plus 25 minus 15. So that is technically sine of A minus B. Now that tan 165, you can put that into your calculator and you should obtain negative 0.27. Okay, so put tan of 165 into your calculator and you will get negative 0.27. Now, from there, all we now need to do is simplify what's in the bracket. So if we were to simplify what's in the bracket, we would end up with x plus 10 equals negative 0.27. Now from here, this is where the general solution part starts. Remember the three items I mentioned earlier? The first item that we need to get is our reference angle. So our reference angle is obtained by moving sine to the other side. But always remember, when you're getting a reference angle, never put in the negative sign. So this is the formula that you can use for reference angle if it's a sine. So you'll say sine inverse of the right-hand side. And it must always be positive. Don't ever put a negative in there, okay? Always keep it positive. Your reference angle must always be positive. So that is then going to be our reference angle is equal to, so on our calculator, we are going to put sine inverse of 0.27. If you don't know how to get sine inverse on your calculator, you press shift, then you press sine. That will give you sine inverse. Now our reference angle is going to be positive 15.66 degrees. That is our reference angle. That is the first important item that we needed to identify. Next, we need to identify which quadrants is sine positive or negative in. Now, if you look at our last or second last step, sine of x plus 10 equals negative 0.27. We are now stating, or the question is now stating, that sine is equal to a negative value. That is negative 0.27. So that means that we need to get sine in the quadrants whereby it is negative. So we ask ourselves, which quadrant is sine negative in? And sine is negative in quadrant 3 and quadrant 4. Keep in mind that everything is positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cos is positive in quadrant 4. So the only quadrants whereby sine is not positive, meaning that sine is negative, is in quadrant 3 and 4. So we are going to break up our answer into two separate parts. We're going to break it up into an answer that will be located in quadrant 3 and an answer that is going to be located in quadrant 4. So we essentially going to have two answers. Now, that was the second item of importance that I previously mentioned. The third item of importance is that you need to know your reduction formula. So this is how we write it. We write our angle, which is x plus 10. You always write whatever is in the bracket. If we had 2x in the bracket, or 3x, or x plus 20, x minus 5, whatever was in the bracket, that's what you bring down. Once you get this, all you now need to do is put that into your calculator. That sine inverse of 0.27, you end up with 15.66. That is your reference angle. That is what we ended up with here. That's what you use, okay? Now, from that point, we needed to identify which quadrants are we going to use. Are we going to use quadrant 1, 2, 3, or 4? How do we know which quadrant we are supposed to use? Now, in order for us to figure out which quadrant we now need to use, we ask ourselves a simple question. Is sine equal to a positive value, or is sine equal to a negative value? Now, as you can see by the step above our reference angle, that is the step that you look at. When you're asking yourself what quadrant to use, always use the step above reference angle. So you ask yourself, am I using positive quadrants or negative quadrants? And how do I know whether I'm supposed to use positive or negative quadrants? Now, the answer comes from what is sine equal to, or what is cos equal to, or what is tan equal to, whatever you are dealing with, what is it equal to? Is it equal to something positive or is it equal to something negative? Now, in this particular case, we have sine of our angle equal to negative 0.27. That is a negative value. So because sine is equal to something negative, we now need to use the negative quadrants, okay? So our negative quadrants for sine, if you don't know them by head, I would highly recommend knowing them by head. But if you don't, draw your cos diagram. So ask yourself, where is sine negative? In the first quadrant, we can see that all are positive, therefore we're not using the first quadrant. In the second quadrant, we can see that sine is positive, so we want a negative sine value, therefore we cannot use quadrant 2, that's out. Now we look at quadrant 3. In quadrant 3, tan is positive, which means sine and cos are negative. Therefore, we can use quadrant 3. If we look at quadrant 4, we can see that cos is positive, meaning that tan and sine are negative. Therefore, we can use quadrant 4. So the quadrants we are going to use are quadrant 3 and quadrant 4, reason being that within those quadrants, sine is negative. If we had sine equal to a positive number, let's say for whatever question we are dealing with, this was equal to a positive 0.27. If it was equal to positive 0.27, we would then use quadrant 1 and quadrant 2, because those are the quadrants whereby sine is positive. So depending on what sine, cos, or tan is equal to, whether it's positive or negative, that is how you decide which quadrant to use. Now, students that are confused on how I'm getting a positive or negative, that is because of the C. C means cos, A means all, S means sine, and T means tan. So if you see A, it means all positive. If you see S, that means sine positive. If you see tan, that means tan positive. And if you see cos, that means cos positive. That is how you identify that. There is a video that was uploaded maybe about 2.5 months back, covering the cost diagram. I would highly recommend having a look at that. It explains your positive angles, your negative angles within a cost diagram. If you do not understand your cost diagram and you're going to write a trig paper, that is an immediate red flag. You cannot go and write a trig paper if you have no idea what a cost diagram is. Everything that you do in trig relies on a cost diagram. I highly recommend knowing it off by heart. So let's move on. Now, we've got our third quadrant. We've identified that we are going to make use of our third quadrant. Now from here, what is this x plus 10 equal to? What is this angle equal to? Keep in mind, because we are using the third quadrant, all you need to do is put the reduction formula of the third quadrant and say plus k times 360. That's all you do when you are doing general solution. You identify which quadrant you're using, and then you put that quadrant's reduction formula plus k times 360. 360 only works for sine and cos. If it's tan, you have to say plus k times 180. So our reduction formula within quadrant 3 is 180 plus the angle, then plus k times 360. Now let's proceed with this. This angle here, This is with reference to our reference angle. That angle means the reference angle. We are substituting the reference angle within that position. Please take note of that. Now let us proceed. Our reference angle is 15,66 plus K times 360. From there, we can add up what is 180 plus 15.66. That gives us 195,66 plus K times 360. Now, once you've simplified the right-hand side as far as possible, this is when you start to change or to move around the left-hand side. Remember, I told you don't touch the left-hand side, just leave it alone. Now is when you start to touch it. You start to move it around to simplify. So this is then going to be x equals 195.66 minus 10. We move that positive 10 to the right-hand side, making it negative 10. And that is plus K times 360. If we had, for example, 2x equals 195,66 plus K times 360, we would have divided both sides by 2, therefore giving us x equals whatever value you get from dividing 195.66 by 2. I'm not going to use a calculator now. I'll just skip it so that we save time. Plus K times 180. Keep in mind you have to divide both by 2. You divide this numerical value and you divide the K times 360. So if it was K times 180, you would have ended up with K times 90. So always keep that in mind. It's still a normal equation. Your normal rules of equations still apply. Okay. Now, let us go back to the original question at hand. Now, from here, all we need to do is subtract that 10. So we can therefore conclude that x within the third quadrant is equal to 185,66 plus K times 360. And when you are getting your final answer for that particular quadrant, don't forget to include where K is an element of integers. Okay. Now let's move on. That is the first, or rather the third quadrant. That is our first part of our answer within the third quadrant. Now we are moving on to the fourth quadrant. Our answer within the fourth quadrant is going to be somewhat similar to the answer, or not the answer, but the process that was used within the third quadrant. So we bring down our angle, which is x plus 10. Equate it to our reduction formula. Our reduction formula within the third, or rather within the fourth quadrant, is 360 minus angle plus K times 360. Now from here, all we are going to do is we are going to substitute our reference angle. Same as before, the exact same process. Minus 15,66 plus K times 360. Now from here, let's see, 360 minus 15.66. All we needed to do was subtract 360 minus 15.66. We end up with 344,34 plus K times 360. From there, because we've simplified the right-hand side as far as possible, we can move that positive 10 to the right-hand side, making it negative 10. So that is going to be minus 10 plus K times 360. From there, we can subtract 10, and that gives us 334,34 plus K times 360. Don't forget that because this is your final answer within the quadrant, you have to include K an element of integers. Now that is how we find the general solution for that particular question. Can you please re-explain the reduction formula? Okay, so the reduction formula part, all you need to do is just put in the reduction formula for that specific quadrant. The reduction formula, it comes from your CAST diagram. So this is your cost diagram, right? Now, this is theta. This is 180 minus theta. This is 180 plus theta. This is 360 minus theta. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Depending on what quadrant you are in, you use the corresponding reduction formula. So I'll do a few examples for you. I've done 3 and 4 already from the question, so I'll do quadrant 1. In quadrant 1, all you need to do is say x equals, so x would represent whatever angle you're dealing with. If it's 2x, x plus 10, whatever it is, it will go on the left-hand side. And that will be equal to your reduction formula, which is theta, represented by an angle, plus k times 360, if it's sine or cos. Now keep in mind, this angle is your reference angle, okay? Then if it's quadrant 2, it's going to be x equals 180 minus that reference angle plus k times 360. Keep in mind that L is your reference angle. Okay, so hopefully that should assist you in terms of the quadrants. Always remember, how you choose your quadrant is based on what that identity is equal to. So if it's equal to something that's positive, you need to ask yourself, in which quadrant is that thing positive? For example, here we had sine was equal to a negative. So we asked ourselves, in which quadrant is sine going to be negative? And that is quadrant 3 and quadrant 4, right? So let us continue. Okay, Kamogelo, you have your hand up, buddy. What's up?
So I would like to ask, don't we simplify x in this case?
When you say simplify x, do you mean like moving the 10 to the other side? Or when you say simplifying x, are you referring to the first question that we did whereby we simplified the expression?
Yes, sir. The first question.
The first one. Okay, excellent. Okay, so you said you didn't understand how we did the first question.
Yes, sir.
Okay, so what the first question, let me zoom in a bit. So the important part was to look at that fraction first, okay? Now, if you look at that fraction, you can see that you can break it up. So this part can be separated. You can have sine x over cos x times tan x. Sorry, that's going to be tan x at the bottom. Because you see, if you multiply sine x times 1, cos x times tan x, you still end up with the same thing, right? You end up back to the original. So we needed to understand that from here, this becomes sine x over cos x, because this is an identity that you should try to memorize, okay? Sine x over cos x equals tan x. So that sine x over cos x becomes tan x times 1 over tan x. That cancels that, leaving us with 1. That is how we ended up with this 1 over here. Are you okay with that part so far?
Yes, sir.
Then there's also another way that you could have done this. So if you didn't want to take the tan approach, or if you did not know, or let's say you didn't want to use this approach, there's another approach that you could have used. You could have said sine x over cos x and then turn this tan x into sine x over cos x. And then cos cancels cos. Then you left with sine over sine cancels, you left with 1. That's a different approach that you could have also taken. Now, in terms of the second part, whereby we have sine of 180 plus x, sine of 180 plus x, we can use our reduction formula to simplify that. So if you go back to the cost diagram that we did, 180 minus x, that is the second quadrant. As you can see, sine is positive. Sorry, let me double check. Was it 180 minus or 180 plus? Just give me a second. It's plus, actually, sorry. So we have 180 plus x. That is the third quadrant. So as you can see, sine is not positive in the third quadrant. It's only tan that is positive in the third quadrant. So when we reduce this, it's going to then become negative sine x. Whenever you reduce something, that 180, that 360, it falls away, only leaving with a variable, which is x or theta or a, or whatever angle representation you were using. So that 180 falls away, and we end up with minus sine x. That is how we ended up with the first one within our bracket. Now, next we have cos of 90 minus x. Now, cos of 90 minus x, because there's a 90 there, that automatically needs to register, okay, I'm dealing with co-ratios. I see 90, that's co-ratios. Always remember. Now, when you're dealing with co-ratios, you can include this into your cos diagram. So as you can see, 90 minus x is within the first quadrant, okay? Now, because it's within the first quadrant, we know that cos is positive. So you put your plus sign. Next, because we're dealing with 90, we need to change this. So cos will become sine and x. As you can see, the numerical value always falls away. Think of the numerical value as a direction. So if you do physics, it might be easier to think about this. You know that when you're doing physics, that angle can sometimes be direction, right? So think of it as, okay, it's moving in a negative direction. That's why I have negative sine x. Or cos 90 minus x, that 90 is moving in a negative direction. That's why it becomes, sorry, a positive direction. That's why I'm left with a positive answer. But I would highly recommend learning your cost diagram. 90% of the trick stuff that we use comes from cost diagram. The other 10% is just algebra and a little bit of trig here and there. Algebra forms about majority of the stuff that you do in math. If you struggle with algebra, if you don't know your algebra rules, math is going to be difficult for you. So I would recommend taking the holiday after your exams, going back to algebra, learning the rules, learn how to manipulate, learn how to play with equations and stuff like that. It makes life easier for yourself, okay? So that is how we ended up with the negative sine x and the positive sine x. From there, we multiplied the two and obtained negative sine squared of x. Thereafter, we know that 1 minus sine squared of x is an identity. It comes from the identity of cos squared x plus sine squared x equals 1. All we need to do is move the cos squared x to the other side, resulting in 1 minus sine squared of x equals cos squared x. That is how we ended up with the final answer. So I'll write it out. Cos squared of x plus sine squared of x equals 1. If we move sine squared of x to the other side, we are left with 1 minus cos squared of x. Sorry, this is supposed to be sine squared of x. Okay, so that's how we ended up with cos squared of x. Kamugelo, are you okay with that?
Yes, sir. Thank you, sir.
If you get stuck with the question, you can attempt it on your own. If you get stuck, you can post a solution in the group. And if I am available at that time when I see it, I will assist you with it, okay? Now, let us quickly try to finish question 5.4.2 before we finish up here. So 5.4.2 states, determine the values of x in the interval x an element from 0 to 360. So our interval is from from 0 until positive 360. So we need to determine for which values of x in the interval 0 to 360 for which f of x will have a minimum value. Now, a lot of students will look at minimum and then start to panic and not know what to do. Please keep in mind that minimum refers to your turning point. So if you think about parabolic functions, right? Let's look at a smiley face parabolic function. This point here, this is your turning point. Because it's at the bottom, it was usually referred to as your minimum. If you look at a sad face parabolic function, this is your turning point. And that is because it's on top, it's referred to as your maximum. Now, this concept will apply in any type of function, and it will apply in calculus. I'm sure most of you have done optimization, and you've seen those questions whereby they ask you to calculate something with regard to a minimum or maximum. Technically, what they're asking is they just want you to calculate the stationary points or the turning points. It's not a complex question. You've done it multiple times before. You're just calculating turning points. That's it. So please don't get confused when they use the word minimum or maximum. They're just referring to the turning points or stationary points. Okay, it's the exact same procedure when you're doing calculus. Keep that in mind. It's important. Now, for this particular question, they want to know for which values of x will there be a minimum. So what we are going to do is we are going to first plot our function. If you already know the function by head, you do not need to plot the function. But if you don't know the function by head, I would recommend plotting it. Okay, so let's go down and plot. So this is question 5.4.2. So we've got f of x equals, and we had that whole long equation, which was sine of x plus 25 cos of 15 minus cos of x plus 25 sine of 15. Now, we previously simplified this entire function using our compound angle formula into sine of x plus 10. That's our function. Now, hopefully you should know the basic function of sine. So I'm now going to plot the basic sine function. If you know the basic sine function, you'll be able to do any function within sine. All sine functions are just reflections or translations of the basic sine function. So I would recommend going and learning your basic sine function if you do not already know it. So let us plot our basic sine function. From there, we will shift it with reference to x plus 10. So let's have it here. That is going to be our axis. So this will be our x-axis, and this is going to be our y-axis. Now, our basic sine function, let's put in some values. This is going to be 90, this is going to be 180, 270, and 360. We'll make this positive 1, we'll make this minus 1. Now, our sine function, you know, at 0, it's going to be 0, goes up to 1, goes back down to 0, goes to negative 1, and goes to 0 again. So you can connect this. Okay, so this is our basic sine function. Now, if you notice, if you were to break it up at this point, does it not look like two separate parabolic functions? So you can think of it like that to get your minimum and maximum. Or another way of thinking about it is the highest point will be your maximum, and the lowest point will be your minimum. So as you can see from the basic sine function, the minimum is represented by 270, okay? So when you're dealing with the basic sine function, x is equal to 270. This is your minimum. Now, if we have x plus 10, is that graph shifted 10 units left, 10 units right, 10 units up, or 10 units down? How do we know? Now we know that because it's in the bracket. If it's within the bracket, it refers to a horizontal shift, meaning the left and right shift. If it is outside of the bracket, it then refers to a vertical shift. So if we had plus 2 outside the bracket, this means 2 units up. If we had -2, it would have been 2 units down. But because our 10 is within the bracket, it is now referring to a horizontal shift. Now, how do we know whether it's going to be 10 units right or 10 units left? Something very important. When you are dealing with vertical shift, positive sign means up, negative sign means down. When you are dealing with a horizontal shift, everything is the opposite essentially. So if it's a plus sign, it means left. If it's a minus sign, it means right. So I'll make a note of that. So +10 means left and -10 means right. Horizontal shifts are the opposite. It's the same with parabolic functions and hyperbolic functions and cos and tan functions. If it's +10, it's left, -10, it's right. Now, our minimum value is here by 270. If we shift this minimum value 10 units left, that is then going to give us 270, because 260, not 270. So if we shift from 270, if we shift 10 units left, we are getting 260. Because remember what I said, +10 means left. We have +10. So take 270, shift it 10 units left. You get 260, okay? So y equals sign of x plus 10, shift it 10 units to the left. It then becomes x equals 270 minus 10, which then gives us 260. So our value of x that is going to produce a minimum value when our basic graph has been shifted 10 units left is going to be 260. So the important thing that you need to understand in order to answer this particular question is that you need to know your basic sine graph. In addition to that, you need to know that +10 means shift 10 units left. -10 means shift 10 units right. As long as it's within the bracket, it is referring to a horizontal shift, and you do the opposite of the sign. Plus means left, minus means right. But if it is outside of the brackets, it is then a vertical shift, which means plus is up, minus is down.